In this video, we're going to talk about part one of the fundamental theorem of calculus and see it written out in all of its logical glory. All right, so here it is. If little f of x is continuous over an interval from a to b, so notice that a is just any real number, and the function big F of x is defined as the definite integral from a to x of f of t dt, then the derivative of f, big F, is equal to f of x over that interval that it's continuous on. Okay, and notice that this is part one of the fundamental theorem of calculus. So just to give you a reminder, part two was the thing that said that if f is continuous and big F prime of x is equal to little f of x. So if this is an antiderivative, then the definite integral from a to b of f of x dx is equal to big F of b minus big F of a. Okay, so what we're seeing here in the fundamental theorem of calculus, they're not saying the same thing. These are saying very different things, but what they have in common is they're talking about how integrals and derivatives are the inverses of each other. They undo each other in some real sense. All right, so here's a function where we start with little f, we take a definite integral, and then we take the derivative of the function that comes out of that, and we got back where we started again. And here's another thing where if we take a function that's, again, f, kind of big F of f, if we take the derivative of big F and then take the definite integral of that derivative, again, we get back to big F of x. Okay, so these are the two forms of the fundamental theorem of calculus. I'm kind of belaboring the point that one of them is named part one and the other one is named part two, and it's kind of, you know, the way we name it is kind of important and a little bit silly. But in practice, you can just call the fundamental theorem of calculus anytime you're using either of these principles, and it will be obvious from context which one you're talking about. All right, in the next video, we'll take a look at a couple other applications of the fundamental theorem of calculus, and we'll also start looking at a generalization of the fundamental theorem of calculus that uses the chain rule to give a slightly broader result.